Okay, so on this next page, what we're going to do is we are going to use our division property. So our division property says that for a number a that is greater than or equal to 0 and a number b that is greater than or equal to 0, if we have the square root of a over b, that actually just means that we've got the square root of a divided by the square root of b. Okay? So an example of this is if we have the square root of 36 over 49, we can actually just say that that's the square root of 36 over the square root of 49. And the square root of 36 is just 6. The square root of 49 is just 7. So that 6 over 7 is going to be our answer. So when a radicand has a denominator that's a perfect square, it's easier to apply the division property first and then simplify the numerator and denominator. When the denominator of a radical is not a perfect square, it might be easier to simplify the fraction before we use the division property, and you'll see that in this. So we have the square root of 64 over the square root of 64 over 49. So I'm going to simplify this using the division property first. So we know that we can make the square root of the top over the square root of the bottom. So the square root of 64 is just going to be 8. And the square root of 49, we've already said, is just going to be 7. So that should be super simple. Over on this other one, our denominator is not a perfect square. So what we want to do first is we want to simplify the fraction inside of this first. So the one thing that I can tell is that we've got an x on the top and an x on the bottom. So we've got 3 x's on top actually and just 1 x on the bottom. So if we cancel this x out and we make this x cubed and x squared, that leaves us with x squared on the top. And 8 and 50 are both divisible by 2. So if we divide both of those by 2, that's going to give us 8 divided by 2, which is 4, over 50 divided by 2, which is 25. Now that we've got 25, which is a perfect square on the bottom, we can use our division property. Okay? So we are going to take the square root of 4x squared. So the square root of 4 is just 2, and the square root of x squared is just x, over the square root of 25 should just be 5. Okay, so go ahead and start working on your got it problems. For a, we have the square root of 144 over the square root of 9. It's going to give us 12 over 3. When we do 12 divided by 3, that's just going to give us 4. And over here, we're going to simplify the fraction first. So both of these can be divisible by 4. So that's going to leave us with 9 on the top and 1 on the bottom. And we've got an a on the top and 3 a's on the bottom. So on the bottom over here, we're going to have a squared. So now we're going to use our division property. So we're going to have the square root of 9 over the square root of a squared, which leaves us with 3 over a. Okay. Our next one, we've got a perfect square on the bottom. So if we have 25y cubed over the square root of z squared. So we know the square root of z squared is just z. The square root of 25 is 5. And our square root of y cubed, if we have y times y times y, we have one pair of y's. So we're going to pull one y out and we're going to leave a y on the inside. So we should have 5y square root of y over z. Okay. So rationalizing the denominator means that we are going to rewrite, it's rewriting a radical expression so there are, not is, So there are no radicals in any denominator, and no denominators in any radical. Okay, so to do this, we're just going to multiply the numerator and the denominator by the same radical expression that's in the denominator. Okay, so for this first one, we've got the square root of 3 over the square root of 7. We know that we can't technically take the square root of 7 to get a perfect number. So what we're going to do is we're actually going to multiply both the top and bottom by the square root of 7. When we do that, we have 3 times 7, so that's going to leave us with 21. If we have the square root of 7 times the square root of 7, that's going to leave us with the square root of 49. And we know that the square root of 49 is just 7, so that leaves us with the square root of 21 over 7. And that's going to be our answer. So anytime we multiply the square root times the same square root, you're just going to get what is in what that radicand is, which is 7 right here. So we've got the square root of 7 times the square root of 7. That's just going to leave us with 7. Okay, so it's the same thing over here. What we're going to do is we're going to multiply both of these by the square root of 8n, top and bottom, by the square root of 8n. Okay, so if we do the square root of 7 times the square root of 8n, that's going to leave us with the square root of 56n over 8n is going to be on the bottom because the square root of 8n times the square root of 8n just leaves us with 8n. Okay, and we can factor something out of this radical. So if we do 56 divided by 2, that leaves us with 28. And divide that by 2 leaves us with 14. Divide that by 2 leaves us with 7. So we've got a pair of 2's right here. That means we're going to have 2. On the inside, we're going to have 14 n over 8n. So the last thing we need to do is simplify what's on the outside. So we know that we can divide both this 2 and this 8 by 2. That leaves us with the square root of 14n over 4n. And that's going to be our answer. Okay, so go ahead and work on the got it problem. So we're going to have times the square root of 3. That leaves us with the square root of 6 over 3. And on this one, we've got times square root of 18m over the square root of 18m. That leaves us with the square root of 90m over 18m. So 90 divided by 2 is 45. Divide that by 5, that gives us 9, and divide that into 2 3's. So that leaves us with 3 square root of 10m over 18m. So 3 and 18 are both divisible by 3, so we can simplify it. That leaves us with the square root of 10m over 6m. That's going to be our answer. And our last one, we've got the square root of 7s over the square root of 3. We're going to multiply both top and bottom by the square root of 3, which leaves us with the square root of 21s over 3. Okay, and that should be it.